Hi, this is Daphne with Rampart AI. With cyber threats increasing every day, the Rampart AI team put together a step-by-step run-through on how to stop a zero-day threat using the Log4Shell exploit. Rampart protects against zero-day attacks. This is highlighted against the Log4Shell vulnerability, where Rampart provides protection without any knowledge of the CVE. Rampart protects your system while your team works on a patch for the next release cycle. Rampart provides a resilient solution that is focused on ensuring your application runs as expected. In this video, Rampart AI's CPO Jacob Staples takes you step by step explaining the exploit, how you can block it, and showcasing how a resilient application acts. Now, over to Jacob.
Hi, I'm Jacob Staples. I'm the Chief Product Officer at Rampart AI. And today I'm going to be walking through a demo of Rampart's defenses against Log4Shell in an environment we call the Rampart Cyber Range. Just a quick intro to the Rampart Cyber Range. Probably the best way to test a defensive technology like Rampart is to see how well it protects you from real-world exploits. And that's essentially why we made this cyber range in the first place. Basically, the range is a safe, isolated playground, if you will, where we can deploy applications with known vulnerabilities and then test Rampart's defenses against those vulnerabilities. So momentarily, I'm going to use a browser interface, which you can see here, to interact with services that are deployed inside of the Rampart Cyber Range, and I'll show you Rampart in action. The app that I'm going to be demoing today is called Logjam, and Logjam is really just a basic Spring Boot web service that we pulled off GitHub. And we picked it off GitHub because it's essentially a Log4Shell proof of concept. So it's something that we didn't write, someone else wrote it. It's third-party code, and it has a susceptibility to the Log4Shell exploit. It has a REST API, and like most apps, it's going to log requests that it receives. And again, critically, it logs those requests using a version of Log4j that's susceptible to that Log4Shell CVE, which is CVE 2021-44-228, which was published way back in December of 2021. It was discovered a bit before that, but it was officially published in December 21. There were several follow-on CVEs because the original patch didn't quite fix everything, and we're just going to focus on the very first one in this demo. So what I've done in our cyber range is I've deployed two instances of Logjam. They're the exact same app. In other words, if you were to do a SHA-256 on both jars, they would match because the files are identical. So in other words, the code is not different between them. The Logjam red service is going to run with no defenses in place, and I'll show you that it's trivially exploitable. That's why everyone is so worried about Log4Shell. And what we're going to do is we'll show you the Logjam green service, which is going to run with the Rampart agent attached. And I'll show you that endpoint is not susceptible because Rampart prevents the exploit and generates alert telemetry. There are three stages to the playbook that I use in this demo. First, the attacker is going to spawn a reverse netcat listener. Then the attacker is going to spawn a malicious LDAP server. It's going to return a malicious Java object via the JNDI protocol. And when that object is deserialized, it's going to execute a command of the attacker's choosing. And then finally, the attacker is going to make a request to the server. And all that matters is that some string in that request is logged. And that's how we're going to trigger the JNDI lookup over LDAP. And that's how we're going to execute code on the server that we're attacking. Anyway, that's a lot of talking, so let's start doing it. Let's see something in action. So what I'm going to do first is run the exploit against the Logjam red endpoint and show you that it works. And this is kind of like the magician rolling up his sleeves. And really what I'm doing is just proving to you that there's a vulnerability that we need to fix. So I'm going to try after this the exact same exploit against the green endpoint, which is protected by the agent. But for now, I'm focusing on the unfortified endpoint. So we should see some adverse behavior here. So the first order of business is to spawn a netcat listener on port 1234. So I'm just going to paste in some commands here with a timeout of 2 minutes to do nclnvp on port 1234. So there's our listener. It's going to wait for 2 minutes for any incoming connection. The next thing I'm going to do is spool up a malicious LDAP server, the one that I mentioned earlier. And this is going to return a Java payload that runs a command on the attacker's behalf. And that command is going to actually connect to what I just fired off in terminal 1, that reverse netcat listener. So I'm going to this thing. There we go. So our LDAP server is up and running. And then the third piece, like I hinted at earlier, is to make a request that's going to contain that JNDI lookup directive in a header value. And when that string gets logged, it's going to give me a shell into the server via terminal 1, which I set up earlier. So here we go. And you can see all that I'm doing is I'm passing this JNDI LDAP string as a header value, the XAPI version header. So I fire this off, and we get a hello world response. So it's not immediately obvious that something bad just happened. However, we go back to terminal 1, and this listener that was listening before just got a connection. So that means that I'm in, and I have a shell that I can use as a foothold for surveillance, for lateral movement, stealing data. I can use it for mining cryptocurrency, whatever I want to do. In this range, the attacker is only interested in capturing flags because that's the purpose of the range. So let's do that. The first thing I'm going to do is read the contents of a flag file. This random looking string, and then I'm going to capture that flag. And this is just a mechanism of verifying that I, as an operator inside of the range, have done something interesting. So there we go. I just captured a flag in this environment. So that really sets the stage for the need for Rampart. Think back, only half a year ago, but think back how many defensive tools there were in place, and yet folks were still absolutely scrambling and struggling to contain this exploit when it came out. I mean, even today, it's not obvious if someone knew about this thing or used it before it got officially, in quotes, discovered. And because Log4Shell had that unique characteristic of being very easy to exploit, and it also resulted directly in RCE, it's the kind of thing that keeps security teams up at night. And let me tell you, the bad guys, once this thing was released, were absolutely hammering on just about every endpoint they could to try to use this to their advantage. So anyway, what we're going to do now is run the exact same experiment against the Rampart fortified green endpoint. And remember that it's the exact same application. The only difference is when I make that request in terminal 3, I'm going to use a different endpoint. So first thing I'm going to do again is I'm going to spawn my netcat listener. Exact same command I ran before on port 1234. All right. Now I'm going to spawn the malicious LDAP server. And the other one has timed out, so I'm just going to start up another one, which will live for another 2 minutes. And finally, I'm going to make a request to this server. The playbook up to this point has been identical between the two attacks, but the only difference in the command I'm about to run is that it's going to hit a slightly different endpoint. So instead of the logjam red endpoint, I'm going to hit logjam green. So you can see before I had logjam red. Now I'm going to hit logjam green. Otherwise, everything is completely identical. So I fire this off. And as before, I get back my hello world response. So it's not, again, not immediately obvious whether something worked or not. We have to go back to terminal 1. However, unlike before, right now the attacker is getting a big fat nothing. There's nothing happening here. There's no connection received. We go over here and look at the LDAP server. In fact, the LDAP server isn't receiving any requests either. So basically what happened was that Rampart saw the app doing something unusual, something that it hadn't seen before. And in this case, that was trying to use LDAP during the processing of a log message, and it prevented that from happening. So to give you more insight in what's going on here, let's take a look at some of the telemetry that Rampart emits and kind of go from there. So here we see the events that Rampart generated during the past 15 minutes. What I want to point out is that right now we're using Elasticsearch as our sort of like SIM environment. There's no requirement to use Elasticsearch. You could use whatever stack whatever you want. You could use just a database. You could even dump stuff into a file, CSV file, whatever sort of ecosystem you want to dump event telemetry into, Rampart is configurable and supports that. But for the purposes of this demo, we stood up Elasticsearch. Basically, what Rampart tells you is it gives you a list of events and it ranks them and organizes them by their perceived severity and the action that Rampart took. So in this case, the JNDI lookup attempt was blocked, so it falls under this bucket right here. But there's also a bunch of other stuff that happened that got picked up by Rampart as unusual. And it wasn't blocked, but it was alerted. And each of these events gives you a very deep dive into what happened and where. Each of the events carries a full stack trace, so you can kind of reverse engineer where exactly in your code this badness happened. You can go all the way down into the raw event telemetry and look at the raw documents and kind of see what's inside of them. So here we have a previously unseen method body being executed. It was a Log4J message parameter formatter. And this was one that wasn't hit until our request header with a weird looking string came in and wound up being logged. And then you get, again, like this massive stack trace. This is a pretty big field, and this would be mostly useful for developers, but it is very good to have this because you can tell exactly where in the code something went off the rails. Now, kind of as a thought exercise to differentiate Rampart from other technologies, consider what would have happened here if JNDI and this LDAP stuff was actually a valid use case for your system. Like, let's say you did want to use JNDI and LDAP to somehow retrieve a login configuration or something from a server. So in that scenario, Rampart would have seen it previously in your test environment, and it would have allowed that to occur. In this specific exploit, though, what it would have blocked is the attempted runtime exec that the attacker introduced as part of their malicious LDAP payload. So in other words, Rampart isn't really enforcing some arbitrary heuristic or signature of attack. And there's a lot of other technologies that do that. What it's doing is learning what the app does and alerting you to anything else that happens in your production environment. And that gives it the ability to handle a wide range of vulnerabilities, even ones that we don't know about, in a way that's really orthogonal to existing approaches. And that is what makes Rampart uniquely valuable as a technology. I hope you enjoyed this demo. We plan to do these in the future for other exploits, kind of as they come out. So thanks for watching.
Thanks, Jacob. We hope you take away from this demo that Rampart allows your application to stay up and running during attacks, creating a resilient solution that is needed for businesses and organizations to function in the world today. As you saw, Rampart prevents the zero-day attack. And with Rampart, you can patch your system at your convenience since your application will stay running as usual. For more information about this solution, head to rampartai.com and feel free to reach out through our website or through social media. Until next time, stay secure.